G'day viewers, well I've taken this terminal cover off here before off camera. And yeah, I've done some studying in this wiring diagram. So we've got R1 which is active going through the switch. Then that comes out to active to this wire, through the load. And neutral comes to this one, through the switch. It comes out of that neutral to the load. Then the potential coil here, for one phase, goes jumped from there, from active to the load to here, and that potential coil is obviously jumped elsewhere in the meter. So yeah, I pulled a cover off to try and get a better understanding, because it is a two-phase meter. I didn't mention that in the previous video. So sort of find out how to wire the potential coils up so they're both getting 240 volt, not 120 volt each, otherwise I might not run at the correct speed. Okay, viewers, got the cover off. So you got your power going into this potential coil, or the voltage coil here. Comes out up there to 1, and you got a neutral from that potential coil coming to here, which I've jumped into this active, so the current's going that way through the coil. Then the second potential coil, which is this bottom one, jumps off this second one also, so we've got power going through there, and a negative of that one goes through to this one, which is going negative off the load, so it should be working alright if I understand that correctly. So basically what I've done, I've got 240 volt through there, activated there to the load, which I've jumped to get this coil here I've jumped to get this potential coil here to get the to work. So I've got 240 volt going to that one there also, so they're both on. So you've got the potential coil here, so that was jumped to that to get that potential coil to work. Power comes out to the load, which is active, and neutral from the supply comes in here through the switch and that coil and out to here to the supply. So it should work correctly if I understand my wiring correctly. So we got through that coil there, that top one comes back out, neutral, which is this one, which current's going through that, and they've jumped it so that gets power, so back through there, and that's working the right way. And neutral comes out through there, the bottom potential coil, which gets us active from this one, so that should work. So yeah, that meter should run at the correct speed if I've fully understand that correctly. So now I'm going to try and now that I've done that, I'm going to put the cover back on and test it with the load, and yeah, because I can't stand it up without the cover. It's going to be a bit hard to see that disc move, so let's try loading it and see how it works. I guess I'm going to hook a lead up to this and see what happens. Heater, 10 amp load here. There's no 1/10 kilowatt hour reading, so just going to take some time to do an accuracy test on this one. You can just see the disc is moving. It is working, so okay viewers, they're all hooked up. Okay, so output of this meter, output of that, input of that meter. So that one's going, that one's going. They're both running. Looks almost the same speed too. Open this up so the hot air gets out. So if that meter is accurate, I'd have hooked it up correctly. Good to see it without the cover, but I need to make some sort of way of holding it with the front cover off so we can see the mechanics moving. Yeah, looking at it like this, the disc speeds look like they're going the same. Let that go for 1/10 per kilowatt hour. See how much it's moved. At least I know it's working. And more importantly, the disc is spinning the right way, so that's good. And the one's moved up slightly, so that's good. That needle's moved slightly toward the 9. So this thing probably would still be accurate. I need to get a good guide here to know for sure. So obviously this disc is spinning obviously slower than this meter. This is 400 revs per kilowatt hour, which is 162.5 revs per kilowatt hour. Heater's definitely getting hot though, so mess that off. Meter stops. Viewers, this thing really wasn't too dirty at all. Bit of methylated spirits and it came up a little bit better. So yeah, I'll have to pour the case off again and just give it a light of dust over inside with some compressed air, because there's tiny bits of hair floating around in there. So yeah, let's open it up, and got the tanks all charged up here, so let's go. Viewers, I got light dust over with some compressed air. I picked up most of the stuff off the magnets and most of all the hair's come out. It's got the tiniest bend here. I did manage to straighten it out a little bit, but it's the best I could do without warping or damaging or scratching the fascia here. So yeah, that drives that, and that kilowatt hour register is driven with this, which drives this, which counts how much this is used up on your coin. So yeah, this acrylic disc, whatever it is barely worn, so it's good. So yeah, just put the case back on, flip it over, and just go over the back a little bit more with some cleaner, so just shine this case up. At least I know it works alright, so that's good. Okay viewers, well that came up alright with a bit of a clean. I mean, I could do it on a new paint job, but it's probably not really worth it. It looks alright just the way it is. It really just adds to its originality, so yeah, guess I'll set it back up over there, and in part 3 I'll do an accuracy test. So for now, thanks for watching.